Erwin Schrödinger, an Austrian physicist, is regarded as one of the founders of quantum mechanics. But he's better known for something he never did. This is a thought experiment for cats. He imagined putting a cat in an airtight box with a device that has a 50% chance of killing the cat within an hour. "How's this cat?" he inquired at the end of the hour. "The cat is either alive or dead, according to common sense." However, Schrödinger pointed out that, according to quantum mechanics, the cat is both dead and alive at the moment the box is opened, both at the same time. We can only see one specific case when the box is opened. Until then, the cat represents a hazy mass of possibilities. Half of it is one thing and half of it is another. That sounds absurd, and Schrödinger thought so as well. He found quantum physics to be unsettlingly philosophical. As a result, he abandoned the theory he helped develop. He began writing about biology. As absurd as the concept of a Schrödinger's cat may appear, it is very real, in fact, fundamental. If quantum objects cannot exist in two states at the same time, the computer on which you are viewing this video will cease to exist. Superposition is a quantitative phenomenon. It stems from the dual nature of everything's waves and particles. A wavelength is assigned to any object that extends through an area of space. That is, it holds multiple positions at the same time. The wavelength, however, cannot be determined. To extend in a very small area of space, an object must exist in multiple wavelengths at the same time. And we don't see these wave properties in the things we work with every day, because the wavelength decreases with increasing motion, and the cat is heavy and somewhat oversized. If we enlarge one atom to the size of the solar system, the wavelength would be a cat attempting to flee from a physicist. In the solar system, it is as small as one atom. Because this is too small to measure, we don't see the cat's wave behavior. A small particle, such as an electron, on the other hand, can demonstrate its dual nature clearly. If we fire electrons into two narrow slits in a barrel one at a time, each electron on the far side, like a particle, is detected in one location at a specific moment. However, if you repeat this experiment several times, with tracking of each individual monitoring, you'll notice that they form a pattern that is typical of wave behavior. A group of band spaces with many electrons is separated by electron-free spaces. These strips will vanish if one of the two slits is blocked. This demonstrates how the pattern is generated by each electron passing through the two slits, both at the same time. A single electron cannot choose whether to move to the right or left. Rather, it moves to the right and left simultaneously. An electron near an atom's nucleus is in an expanding, wave-like orbit. When two atoms are brought closer together, electrons would not need to choose just one atom, but it is shared by both. Some chemical bonds are formed in this manner. The electron in a molecule can be found in both atoms A and B. A will spread out more electrons as more atoms are added. It is shared by a large number of atoms all at once. In a solid, electrons are not bound to a specific atom. However, it is shared by all atoms and spans a large amount of space. It defines the massive superposition of states as well as the movement of electrons through matter, whether the material is conductive, insulating, or semiconducting. It enables us to comprehend how electrons are shared among atoms, controlling the properties of semiconductor materials such as silicon precisely. We can make transistors on a small scale, millions of them on a single computer chip, by properly combining different semiconductor materials. These chips, as well as their scattered electrons, turn on the computer you're using to watch this video. According to an old joke, the internet exists to share cat videos. However, on a much deeper level, thanks to the internet and an Austrian physicist and his imaginary cat,